Hello everyone, I hope you're doing well. Today we're going to be taking a look at just sort of some nice math exploration things about exponents regarding negative exponents and rational exponents. How do we get the conventions that we already have? And just a little interesting. It'll be a short video. I just wanted to talk about it a little bit. First thing we're going to look at today is how is it that negative exponents work? Why is x to the negative 1? Why is that 1 over x? Okay, and I'm going to essentially prove that this is true. So what I'm going to start with is that 1 over x is equal to x to the k. Okay, and we're going to try to solve for k. Essentially, our goal here is to solve for k. Right? What does k have to be to make this equation true? Right? So I'm going to do this just by starting by multiplying both sides by x. So I would get 1 equals x to the k. Okay. Then I would do 1 equals, using my power rule here, it would be x to the 1 plus k. Next, I want to rewrite 1 over here as x to the 0. So I'm going to write that on the next line. X to the 0 equals x to the 1 plus k. The reason I do that is because now I see that it's x to some power equals x to some power. The only way that happens is if the powers are equal. So we get that 0 equals 1 plus k. Essentially, this is implied from that equation. And finally, we can just solve that k equals negative 1. So the only solution for k here, to make that equation true, is that k has to be negative 1. So I also wanted to talk about, so there's our kind of proof for why x to the negative 1 is 1 over x. Let's also quickly talk about why is the square root of x equal to x to the 1 over 2. Okay, and then we'll do a more general version of this after. I'm going to just essentially start the same way as before. This is our goal. I'll box it in green. Right, just like up here, this was our goal. Box that in green. Why is the square root of x equal to x to the 1/2? Well, let's start with the square root of x is equal to some x to the k. Okay, I don't know what k is. Let's just try to solve for k and figure out what this would be. So I'm going to square both sides. So that would be x equals x to the k squared. Okay, x equals, this would be x to the 2k. And the power here is 1. Again, same situation. If I have x to some power equals x to some power, those powers must be the same. So 1 equals 2k, which tells us, so this is implied from that equation, which tells us that k equals 1/2. So we can see here that, again, the only solution for k is that k must be 1/2. Finally, let's do this a little bit more generally, right? What if I had x to the a, or the bth root of x to the a? Pretty much, that's how you'd say that. We know that this is x to the a over b, right? But again, let's prove it. Let's actually prove that this is true, right? So if I start with the bth root of x to the a, and I'm going to say this is equal to some x to the k. What does k have to be here? Well, again, I'm going to use the same method. I'm going to put both sides to the power of b, right? So I'm actually going to explicitly write that here just to be clear. Put both sides to the power of b. And I would get then on the left side, this is just x to the a. And on the right side, this is x to the kb. Right? And once again, I can see here that I have x to the some power equals x to some power. Those powers must be the same. A must be equal to kb. In other words, k equals a over b. Right? So we can see that the only solution to this equation that makes it true is if k is equal to a over b. In other words, that x to the a over b is equal to the bth root of x to the a. The reason I wanted to make this video at all was because I think a lot of people think this is kind of a notation trick more than actual fundamental math, right? That we just choose to call 1 over x x to the negative 1 and the math works out. But that's not actually true. That this is actually the only exponent that would make sense to be 1 over x is x to the negative 1, right? That is the only thing that would make sense. Similarly, the only exponent that would make sense to replace the bth root of a is a over b. And that's because, when you try to solve for it, when you try to define it, that's what you have to get. So it's actually something, ingrained into our algebra rather than just a notation trick. Well, I hope this was interesting. Thanks so much for watching. If you have any questions, let me know, and I hope you have a great day.